Fordham here, and we're talking about functions today, and more specifically quadratic functions. So what I have here drawn is an example of a quadratic function, and please excuse my awesome drawings, but didn't go to school exactly to be an art teacher. So the big things you need to be able to focus on for functions is domain, range, the x and y intercepts, and whether or not it's a function. Now, because everything is very specific to quadratics, most likely the answer to all these questions today for a function is going to be yes, but we'll still cover it. For domain, remember, domain, another way to write that, if we want to put this off to the side, is x values. We're talking about the x values for the domain, and the range we're talking about y values. So what we want to do is look at our graph and see what are all the possible x values that we can have for our domain. So when we look over here, we see that the graph is kind of tailing slightly to the left, but it just keeps going left because of the arrow, meaning to go forever. Since it keeps going to the left, that means eventually we're going to cover all of these x values with some y value. Now, it's probably going to be really big, but it's still going to have a number. If I were to come up with an equation for this, and it would look something probably like f of x equals x squared plus da 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 da. If I plug in like -6 over here, I'm going to get a really big y value, but I'm going to get a y value. Now we also need to talk about how to exactly write our domain specifically, and to do that we need to talk a little bit about set builder notation and what it exactly is. I have an example here of set builder notation, and I'm just going to actually go ahead and read it first. So this says the set of all numbers x such that x is between -2 and 4. So the little brackets mean the set, and that just tells you, hey, I'm working with a set of numbers here, just get ready. So the set of numbers, and then the x comes in here because that's our identified variable. This little slash right here, or dash, or kind of sideways dash, I should say, always means such that. Literally all it means. And then this tells you exactly what x is doing. So in this example for set builder notation, it looks like the only value x can have is between -2 and 4. So this would be the set of numbers x such that x is between -2 and 4. Now there's one other particular value you might see. Here's another example, and this one's pretty key. You might see this symbol notation, and this would be in here. And this says x is a set of all real numbers, or a subset of all real numbers. So what that means basically is x is any number you can think of that's a real number. So if you see this, it just means basically all real numbers. But the SOL doesn't really write that anymore. They kind of started switching to this notation, which makes sense. I mean, in the math community, this is how we write our mathematics. We don't really write it any other different way. So let's go back to our original problem here. So we're here, and we need to talk about our domain. Like I said, the domain is going to go all the way to the left, and in fact, because the arrow is going this way, it's also going to go all the way to the right. So that means we're basically going to get all the x values. So for our domain, we're going to write, it'd be x such that x is a subset of all real numbers. And like I said, that just means x can be any number we want. It doesn't matter. You can pick an x value, you're going to get a y value. The range, however, isn't the same. The range covers all possible y values. And as you can see with our curve, it goes forever up, but when we try to go down, it kind of like a roller coaster swings around a curve and comes back up. And the lowest y value we have is -4. Now, when it goes up, we can have any y value. It goes on in infinity. So when we go to write our range, we're going to write y such that, and I'm going to put -4 is less than or equal to y is less than infinity. So what this says is we can pick any y value, and it's going to be between -4 and infinity, which makes sense. I could pick 2,000, it's going to be really far up the y scale, but it's going to have an x value. If I pick -5 for y, it's not going to have an x value because our graph doesn't go there. X-intercepts, this is also called sometimes referred to as zeros has the same name. So if you hear zeros, it's the same thing as x-intercept. All you got to do is look at the graph and see where it crosses the x-axis. So for this one, I'm going to write it just as -2 and 3. Again, just using that set notation. The y-intercept, sometimes it's pretty easy. In this case, we can look at it and we can see our y-intercept is going to be -4. And now, final question, is this a function? You've probably learned at some point maybe this thing called the vertical line test. It's where you take your pencil or pen and you drag it across your graph and see how many times the graph touches it. It should only touch your pen or pencil once. If it touches more than once, then it's not a function. In this case, this is a function. Just to give you a really quick example of what a non-function will look like, this would not be a function because when I draw a vertical line, it hits there, there, and there. Another example would maybe be like a circle. You can even tell by the y-axis that hits right there and there. So that also is not a function. So not functions. Don't draw those. But this one totally is. Let's do another quick example. So now here we have a parabola opening downward. So again, we're going to go through the same process. The domain. This arrow means it's going slightly to the left forever, and this arrow means it's going slightly to the right forever. Since it's going to keep going slightly to the left and to the right, and we have all these values, we're going to have the same domain as before. We're going to have x such that x is a subset of all real numbers. Basically just means any value of x you pick, it works. Our range, it looks like our graph maxes out right at about +3. So the biggest range value we can have is +3. But when it comes to the negative values, again, the arrows means it goes forever. So we're going to have any possible y value going down. So to write that, we're going to go ahead and put y such that -infinity is less than y is less than, I'm going to say less than or equal to, because it looks like it touches right at 3. Just like that. Our x-intercepts, again, all you got to do is just look at the graph. It's that simple. So we can see, looks like -3 and then 1, 2, 3, 4, 5. So, -3, 5. And by the way, we've also heard this called more commonly lately roots. So just as before, as we called it zeros, we can also call it roots. It's got a lot of different names. It's pretty popular apparently. All right, our y-intercept. So looking back at the graph, again, it happened to be part of our range. So our y-intercept maxes out, or touches somehow right at 3. I got to get a little better drawing here. It looks like it's slightly below, but we'll assume I meant to hit 3. And again, is it a function? Does it pass the vertical line test? Yep, totally looks like it does. So yes. All right, we're going to take a look at one more graph and then actually a specific SOL problem that I've seen lately. So here we go. Now, this is going to be a little bit tougher to figure out some things. Our domain, though, still the same. As you can tell, the arrow is going slightly to the left, slightly to the right. It's going to cover all the possible x values in both directions. So we're going to write x such that x is a subset of all real numbers. The y value, you can see it doesn't even really get that low. It kind of hits right at about 2. So we're going to go ahead and say that the range is y such that the lowest it can be is 2. I'll say it's inclusive. Y and infinity. Okay. Now the x-intercept. It's pretty clear when you look at this graph that at no point is it going to touch the x-intercept. Your graph comes and turns back up and goes away. So since it's never going to touch the x-intercept, you could just put none. Or you might even see it written as this. And I know I write my 0 like this, but this is specifically called the null set, which basically just means empty. There's no values. More commonly, you're probably just going to write none. Don't write 0 because, remember, 0 is an x-intercept. So I would just say none. You might see this null set thing, which just means empty. Probably just going to write none. All right, our y-intercept. This one's a little tougher to figure out because my y-intercept goes off the chart. But if I were to draw it, 2, 3, 4, oh boy, I got a lot of counting to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it goes all the way up to 11. boys in Spinal Tap would be proud of me. So it goes all the way up to 11, touches right there. And of course, this is still a function. It totally passes the vertical line test. I don't even need to bother checking it. Just be kind of a waste of our time at this point. Now, let's take a look at a specific SOL question that I've seen come up lately. So the question is, they give you this. They say the function is f of x equals x minus 2 squared plus 3. And they also tell you that the domain is the set of numbers x such that x is greater than 0. Basically, it's a fancy way of saying x is positive. So you can have no negative x values, when you can't have 0. Now, the question they had is, what is the range? And the more specific question is, what is the range minimum? So what they wanted you to do is figure out what's the lowest range value you can have. Well, that's kind of tough to do based on just what you're given. So the SOL people thought they'd be really nice, and they even gave us 4 choices to figure it out. So they're saying, hey, the lowest range value is either going to be 2, 3, 5, or 7. Great. How do we do this? Simple. Graph it. It's the easiest way to take care of anything. And all you have to do is just make an x and y chart. If they're going to give me a function to work with, I'm going to generate a table and graph it. Now, some of you might be making this in your graphing calculator, and that's perfectly fine. Just remember, they said that the x values, everything has to be greater than 0. Not equal to, but greater than 0. What I'm going to do is actually start with 0, and just remember, it can't equal 0. So whatever value I get, it doesn't matter. It's just kind of like a starting position for me to remind me where I should begin. So I went all the way down. Looks like I went to 5 on my little table. So when I plugged in 0, I ended up getting the value of 7. And then I plugged in 1, I got 4. I plugged in 2, I got 3. I plugged in 3, I got 4. And then I got 7 over here. And from the table alone, I can kind of see what the value is probably going to be. But me being a visual person, I would like to graph it. So here's that first positive value that I'm seeing up there, 0. Well, technically not positive, but right at the edge of the boundary is 0. Then we're going to go 1, 1, 2, 3, 4 right there. Then we're going to go 2, 3 right there. Then we're going to start curving back up. So it kind of looks like the last parabola we did, where it comes and bends right up there. Now, it works out nice that the value right here of 2, 3 is our vertex. And since our vertex is the highest or lowest point of a graph, of a parabola, that tells us right away that's either a minimum or a maximum. Since this parabola opens up, that's a minimum value. So just by graphing a pretty tough looking problem, we're able to figure out that the correct answer for this SOL problem is 3. And that's how you deal with domain, range, x, y intercepts, and functions for quadratics. Thanks for watching.